At the stroke of the midnight hour, when the world sleeps, India will awake to life and freedom. Scientific temper, on the other hand, is an intellectual disposition, that is, the habit of asking questions, demanding evidence, testing claims, remaining open to criticism, and revising one's beliefs. I want to get into a bit of controversial issue of Andh Bhakti. One way to do it, one way to discuss it without controversy is using logic. Focus on this again. This logical analysis shows that Andh Bhakt is defined by the manner in which they hold a belief rather than what they believe or what the belief is about. Even if you have seen the sun appear to rise every morning since the day you were born, this does not logically guarantee that it will rise tomorrow. That is a problem of induction. Nehru therefore rejects the positivist tendency to treat scientific knowledge as the whole of meaningful human understanding. However, he still asks us to remain firmly committed to scientific temper. This brings us to an important question. Why did Charvakas face so much hostility when they criticized the Vedic tradition? Let us now move to Saint Tukaram, who has shown us scientific temper in a different way in the Bhakti movement. However, if we are to make progress and rise above hatred and division, we must, in Kant's own words, sapere aude.
Long years ago, we made a tryst with destiny, and now the time comes when we shall redeem our pledge.
Hello, namaskar, adab, vanakkam. Article 51A(h) of the Indian Constitution outlines a duty of every citizen, and it says that it shall be the duty of every citizen of India to develop the scientific temper, humanism, and the spirit of inquiry and reform. This article gives us a remarkably unique idea of citizenship. In fact, India is the only country in the world whose constitution makes it a fundamental duty of every citizen to cultivate scientific temper, humanism, and the spirit of inquiry and questioning. That is why it is our patriotic duty or kartavya to develop scientific temper, or in other words, a critical temper towards our beliefs, especially the dogmatic beliefs. With the constitutional duty in mind, let us now examine the idea of scientific temperament. We will examine the concept of scientific temper, which is, in simple words, a method of critical thinking and not believing anything without a rational justification. My reason for choosing this topic today for Independence Day lecture is to help bring what P.N. Hexer called the much needed second renaissance in our country, where the first renaissance was the one which brought us freedom from colonization. So let us begin with the question of scientific temper. What is scientific temper? First and foremost, it is important to clarify that scientific temper or scientific outlook or scientific attitude or critical temper is not a theory of science similar to Newton's theory of gravitation or Darwin's theory of evolution. It is of values. Again, it is a system of values, or in philosophical jargon, a normative social and political ideal. And in Nehru's own words, scientific temper, and I quote, should be a way of life, a process of thinking, a method of acting and associating with our fellow men. Scientific temper demands that we develop a particular process of thought, particular process of thinking. That is, to doubt claims critically, demand evidence, remain open to correction, and reform beliefs and institutions when reason and experience show that they are mistaken. The second point to note about scientific temperament is that it is not limited to science or students of science. In fact, it is more than science and technology, more than having some scientific knowledge. Remember this: a person may be a technological expert in his occupation, may be an IT expert, and still lack any scientific attitude in his socio-political relations. A person may be a scientist, but still support dictators and can be very superstitious. So, being a scientist does not automatically mean you have a scientific temper. It only means that you know how to use scientific methods in only the matters of science, not in society or politics. To this effect, Bertrand Russell writes in his Scientific Outlook 1931 book that, and I quote, "The men of science have shown themselves amenable, and apart from some scientists who were critical of unjust authority, most were willing to acquiesce in governmental doctrines because most of them are citizens first, like you and me, and servants of truth only in the second place." Now, moving to our third point, that scientific temper is different from both scientific knowledge and scientism. Scientific knowledge consists of facts, theories, methods, and explanation produced by sciences. Scientific temper, on the other hand, is an intellectual disposition, that is, the habit of asking questions, demanding evidence, testing claims, remaining open to criticism, and revising one's beliefs when better reasons become available. Scientism, on the other hand, however, goes too far in the opposite direction by treating the methods of natural sciences as the only legitimate means of understanding every human problem, including the questions of morality, politics, art, and value. That is why it can be considered a dogmatic position, a Kattarwadi position, as it has complete faith in science. And if you're scientifically tempered, you would criticize the dogmatic position of scientism, because scientifically tempered person respects authority of science and its methods within its proper domain, while at the same time also recognizing that science alone cannot determine what ends society should pursue. Now, reasoning in science, that is our second topic to discuss. Now, although scientific temper extends beyond science into social and political life, it remains grounded in the habits of scientific reasoning. So, let us briefly examine two basic reasoning used in science, namely deduction and induction. Let us begin with deduction. Deduction is a reasoning in science that moves from general principle or hypothesis to a particular conclusion that follows from it. For example, if scientific theory states that in a vacuum near Earth's surface, freely falling bodies accelerate at a particular rate, we can deduce how far a particular object should fall within a given period. A deductive argument is logically conclusive when its form is valid and its premises are true. Deduction itself does not prove that premises are themselves true. Rather, it guarantees that if the premises are true, the conclusion must also be true. In science, deduction is especially important because it allows researchers to derive predictions from a theory. These predictions can then be compared with observations and experiments. Induction, that is our second scientific reasoning that we are going to discuss, as opposed to deduction, moves in the opposite direction. It is a process of reasoning from particular observations to a more general conclusion. After observing number of cases, we infer that they reveal a general pattern or a law. For example, using Tycho Brahe's detailed observations of planetary motions, Kepler inferred the general laws that describe how planets move. However, there is a problem with induction. It's a very famous problem in philosophy. That is, inductive conclusion is never logically certain because future observations may require us to revise our previous generalization. Even if you have seen the sun appear to rise every morning since the day you were born, this does not logically guarantee that it will rise tomorrow. That is a problem of induction. Induction therefore produces conclusions that are probable, open to correction. Therefore, induction helps us formulate general laws from observed cases, while deduction tells us that what should happen in particular cases if those laws are correct. This is why induction is specially connected with scientific temper. It teaches us to base our beliefs on evidence, hold them with some humility, and revise them when better evidence becomes available. Interestingly, you will notice that both methods of formulating conclusions allow science to move beyond what has already been observed. In fact, it sometimes predicts phenomena that has never been observed. That is the beauty of science. Induction moves from particular observations towards general laws or probable expectations. Weather forecasting, for example, uses patterns found in past and present observations to tell us whether it will rain tomorrow or not. Deduction then allows scientists to derive testable consequences from a general theory. For example, Einstein formulated special relativity in 1905 and general relativity in 1915. However, his prediction of general relativity was famously tested during the solar eclipse of 1919. This is how scientific reasoning works. Now we move away from scientific reasoning to the methods of scientific testing. As we discussed, induction and deduction are two basic forms of logical reasoning used in science. There are also two influential positions in science, philosophy of science, concerning the relations between scientific theories and empirical evidence, namely verificationism and falsificationism. Again, verificationism and falsificationism. This is where scientific temper becomes especially relevant. Let us begin with verificationism. Verificationism is associated with logical positivism, which is a 20th century philosophical movement that emerged in Europe, especially Vienna. The logical positivists argued that factual knowledge about the world must have grounding in experience, and the truths of logic and mathematics are analytic, that is, their truth depends upon their logical form and meaning of their terms. Their philosophical criterion, known as verification principle, can be stated as follows, which is very important. A statement is cognitively meaningful only if either first it is empirically verifiable, or second it is analytic, that means true by virtue of logic or meaning. The first condition is the one that is more important for us in our lecture on scientific temper. It means that factual statements must be connected to possible observations that could provide evidence for or against it. The statement does not need to have been verified already. It only needs to be verifiable in principle. In simple terms, we should be able to say what kind of evidence could support the statement or count against it. According to verificationism, if no possible observation could ever test a statement, then it cannot be treated as meaningful factual claim. Again, a meaningful factual claim. This sort of argument led positivists, logical positivists, to take a sharp radical turn when they applied verification principle particularly strongly to metaphysics, religion, ethics, and aesthetics. They argued that statements which appear to describe reality but have no possible conditions of empirical verification lack cognitive or factual meaning. To understand this, take statements such as the sunset is beautiful, murder is wrong, soul is immortal, God exists. These are not treated as ordinary factual propositions capable of being true or false, and that is why they are cognitively meaningless. However, logical positivism has faced lots of criticism. We will consider some of them. The first criticism I want to bring into discussion comes from our first Prime Minister, Jawaharlal Nehru. Although Nehru urged us to hold on to reason and scientific method, he also recognized the limits of positive knowledge in which science deals. As he writes, and I quote, "Science deals with the domain of positive knowledge, but the temper which it should produce goes beyond that domain. Scientific knowledge can help us understand facts, causes, observable relations. Still, it cannot by itself determine ultimate purposes of human life or give full account of moral goodness, beauty, art, and poetry." Nehru therefore rejects the positivist tendency to treat scientific knowledge as the whole of meaningful human understanding. However, he still asks us to remain firmly committed to scientific temper because, and I quote, without that firm basis and background, we can have no grip on any kind of truth or reality. This reveals an important feature of Nehru's own scientific temper. That is, he recognized the limits of science and reason and at the same time continued to defend them as the indispensable foundations of our search for truth. The second criticism of logical positivism is that finite number of observations cannot conclusively verify a universal law. For example, no matter how many times metals we observe expanding when they are heated, those observations cannot logically prove that all metals will expand under the relevant conditions. Now, this criticism is crucial because it leads us to an influential theory of philosophy of science, that is falsificationism, that is developed by Karl Popper. Popper argued that science does not advance by conclusively verifying universal theories. Instead, this is very important, a scientific theory must make testable predictions and expose itself to the possibility of being proved wrong. Isn't that fantastic? No matter how many times we test to confirm a theory in experience, we cannot establish that it is absolutely true. Nevertheless, even a single observation that contradicts a prediction can serve as a basis to falsify a theory. That is very fantastic. I really love this. Suppose we start with the statement water boils at 100 degrees Celsius. Instead of looking only for example that agree with it, we try to find a case where it may be wrong. So imagine that if we take water on the top of Mount Everest, there we find that water boils at about 70 degrees Celsius because the air pressure is much lower. This shows that our first statement was too simple to be a universal law. Water does not boil always at 100 degrees Celsius everywhere. Its boiling point changes with air pressure. We must therefore replace the old statement with a precise one, that is, water boils at 100 degrees Celsius at sea level. This is how science makes progress, not by confirming our theories, but by falsifying those theories and replacing them with better and more precise theories. This shows an important feature of scientific temper. A person guided by scientific temper does not merely search for evidence that confirms what they already believe. Instead, they ask what evidence would count against their belief. As Popper writes, and I quote, rationality of science lies not in its habit of appealing to empirical evidence in support of its dogmas, but solely in the critical approach. For us, therefore, science has nothing to do with the quest for certainty or probability or reliability. We are not interested in establishing scientific theories as secure or certain or probable. Conscious of our fallibility, we are only interested in criticizing them, the theories, and testing them in the hope of finding out where we are mistaken, of learning from our mistakes, and if we are lucky, of proceeding to better theories. That is really fantastic. I really love Popper. Let us now turn to some of India's philosophical movements where we can see examples of scientific temperament. We will begin with the Charvakas, which is the materialist school of classical Indian philosophy. They are especially important for this lecture on scientific temper because their thought has a strong empirical character and because they criticized the otherworldly beliefs and rituals found in the Karmakanda section of the Vedas. It is important to know that most of what we know about Charvakas comes from the philosophers who opposed them, and we must also remember that most of their original writings did not survive. This is because, as Dakshinarajan Shastri writes, it is probable that advocates of the Vedic orthodoxy, in their fanatical zeal, collected and destroyed the original works of Brihaspati school of philosophy, who is considered the founder of Charvakas. Also, as a matter of historical interest, it is crucial to remember that Charvakas were attacked and insulted by their opponents in those times. Bhupinder Hira makes this clear in his book, and I quote, "The intensity of hatred and vilification towards Charvakas was so powerful that it was castigated as atheistic and immoral." Nevertheless, Charvaka philosophy has attitudes that closely resemble scientific temper. This can be seen in their challenge to Vedic claims based on sacred authority, inherited traditions, priestly status, or fear of supernatural consequences. Instead of asking whether a doctrine had been sanctioned by the Vedas or accepted by religious authorities, they raised a simple question, that is, what evidence do we have for believing whatever the theories? This brings us to an important question. Why did Charvakas face so much hostility when they criticized the Vedic tradition? To understand this, we first need to understand their philosophy, especially their theory of knowledge or epistemology. For the Charvakas, perception was the only dependable source of knowledge, or pramana. Pramana is a source of knowledge. They rejected inference and testimony as sources of knowledge. Let us now understand what they meant by knowledge through perception. For Charvakas, knowledge begins with what is directly experienced through the senses, the five senses, rather than with any sacred text or from invisible realities. This focus on experience gives Charvaka philosophy a strong empirical character, or we can call this worldly character, and makes it similar. Charvakas are similar in many ways with later empiricism in Europe of John Locke and David Hume. Its connection with scientific temper is very simple, that is, our beliefs should be based on observable evidence. Second point I want to note here is that the Charvakas did not accept inference as a certain source of knowledge, because inference moves from what we can observe to something we cannot directly observe. For example, we can see smoke, we conclude that there is fire. In doing so, we assume that smoke is always connected with fire. This universal connection between smoke and fire is called Vyapti. But we cannot observe every case of smoke and fire in the past, in future, or in present. We therefore cannot completely be certain that the connection between fire and smoke is always true. There may be some hidden condition called an upadhi on which the connection depends. Even though Charvakas rejected inference, they recognized that inference can be useful in everyday life. We infer fire from smoke, danger from warning signs, or presence of another person from the sound of their voice. These inferences may help us in actions, but they can still be wrong. This is the reason Charvakas did not accept inference as an independent or certain source of knowledge. Their approach shows both scientific and pragmatic attitude, where an idea may be useful without being absolutely certain. And a few observations may not be enough to prove a universal rule anyway, like we have seen in positivism or induction. Third, the Charvakas applied the same criticism to testimony or sabda. We may hear someone's words through our senses, but we should not accept claims about the things we cannot observe simply because they come from a respected person or sacred book for that matter. Testimony depends upon the assumption that the speaker is reliable or the speaker is credible, and that assumption itself is based on inference, and Charvakas already rejected inference. For this reason, Charvaka rejected the authority of the Vedas. The Charvakas accused Brahmanical priests of promising rewards in another world so that people would perform rituals from which the priests would earn their living. This reflects an important part of the scientific temper, where no belief should be protected from questioning simply because it is old, sacred, or supported by powerful authorities. Finally, Charvakas rejected the idea of any material soul because such a soul can never be perceived. Remember again, Charvaka's epistemology believes only in the knowledge through perception. For them, the self or the soul is the living and conscious body. Consciousness for them appears when material elements come together in a particular way, just as a new quality can appear when different substances are mixed. Therefore, when the body dies, the person also ceases to exist. It never exists after that. Claims about an immaterial soul, rebirth, heaven, hell, or rewards and punishments in another life are therefore not supported by evidence. This is what the Charvakas reject. Charvakas also rejected God for the similar reasons. God cannot be perceived, and the existence of the world does not require a supernatural creator. The world can be explained through natural properties or swabhava of material things and the way in which they combine. Chatterjee and Datta say that this part of Charvaka's philosophy resembles positivism because it accepts only positive facts or observable phenomena, and importantly, its connection with scientific temper lies in its preference for natural explanations over a supernatural claims that cannot be verified. Remember that point. Let us now move to Saint Tukaram, who has shown us scientific temper in a different way in the Bhakti movement. Tukaram was not a scientist, as we all know, in a modern sense, but many of his abhangas show a strong critical outlook. He questioned superstitions, empty rituals, priestly hypocrisy, caste pride, and religious practices performed without any understanding. Take, for example, one of his abhangas. नवसे कन्या पुत्र होती तरी का करने लागे पति जाने हा विचार स्वामी तुकयाचा दातार. That means, if vows or religious promises alone could produce daughters and sons, why would a husband be necessary? This is what Tukaram was asking. Tukaram is criticizing people who depend on priests, vows, and rituals in the hope of having a child, especially son in our society. His question directly ridicules the belief that such rituals can secure a childbirth. He is ridiculing it. If Tukaram had been alive today, he would likely have challenged these practices with the same sharpness and satire. Now remember, A.H. Salunkhe, in his book Vidrohi Tukaram, argues that Tukaram's criticism was also directed against caste-based monopoly over Vedic knowledge, and Salunkhe uses some very stinging words to criticize that situation. And let me quote. Now these are Dr. Salunkhe's words. And I quote, ब्राह्मणांच्या शेमड्या पोरांनाही वेदांचा अधिकार मिळतो आणि दुसरीकडे तुकाराम सारख्या प्रतिभावंतालाही तो अधिकार नाकारला जातो. हा भारताच्या ज्ञान क्षेत्रावरचा कलंक आहे. That means even the immature children of Brahmins receive the right to the Vedas, while a person of Tukaram's intellectual stature is denied that right. This is a stain upon India's field of knowledge. Salunkhe explains that under Dharma-shastric social order, Shudras were denied the right to study the Vedas. The rule was enforced through fear, severe punishments, so knowledge became inherited privilege of only few castes. Against this background, Tukaram mocks those Pandits who could recite the Vedas but did not understand their meaning. He argues that if mere reciting of the Vedas by the Pandits is considered knowledgeable, then we will have to consider the horses as knowledgeable as Pandits, because those horses can carry weights without understanding what the weights are about. This is Tukaram speaking. In this way, Tukaram challenges both parts of the system. He challenges caste hierarchy that kept knowledge away from most of people, and he also challenges those scholars who had access to the sacred text, the Vedas, but did not truly understand them. Tukaram's critical attitude shows his willingness to question authority and refusal to obey unjust authority. This is why we can say that his thought reflects a scientific temper. Let us now turn our attention to statistical criticism of astrology from an experiment conducted in Maharashtra. And I want to specifically discuss a paper by Jayant Narlikar, Narendra Dabholkar, and two others. In this experiment, the researchers tested a specific astrological claim, that is, that a person's intellectual ability can be identified from their birth chart, or we can call that Kundali. They collected the birth details of 200 students. 100 were academically bright students, while the other 100 had intellectual disabilities. Their horoscope were prepared using standard astrological software and then coded, mixed, and randomly distributed so that participating astrologers did not know which chart or kundli belonged to which group. Each astrologer received about 40 charts and had to classify each student into one of the two groups, that is, either intellectual or disability. Since there were only two possible answers, random guessing would ordinarily produce around 20 correct classifications. The researchers therefore determined in advance that an astrologer would need at least 28 correct answers out of 40 to perform significantly better than chance. Remember this number. Each astrologer have to get at least 28 or more to perform better than chance. Astrological institutions were also invited to classify all 200 charts and needed at least 117 correct answers to demonstrate statistically significant success. Okay, they have to get at least more than 117 right. 51 astrologers initially agreed to participate, but only 27 returned with their results. The best individual astrologer classified 24 out of 40 charts correctly, which remained below the required score of 28. Remember, 28 they have to get to perform better than chance, but they got only 24. The average score was only 17.25 out of 40, which was statistically consistent with random guessing. Two astrological institutions agreed to participate, but only one submitted its results. It classified 102 out of 200 charts correctly, whereas it needed at least 117 correct classifications to perform significantly better than chance. The astrologers therefore failed to distinguish academically bright students from the students with intellectual disabilities based on their horoscope, Kundli again. Their predictions demonstrated no reliable ability beyond what could have been achieved by just guessing. Now, let me state the conclusion of this statistical criticism of astrology in simple words. The experiment did not test every claim made by astrologers in general. It tested one clear claim: whether astrologers could identify a person's intellectual ability from their birth chart, or that is Kundli. On this particular claim, their predictions performed no better than chance, random guessing. Additionally, the importance of this experiment lies equally in its method. Narlikar, Dabholkar, and others allowed astrologers to demonstrate their predictive ability. They also defined standards of success in advance, protected the experiment from prior knowledge and bias, and compared results with clear statistical baseline. This is a scientific temper in practice, a claim which is formulated precisely and also exposed to the possibility of failure and judged according to the publicly examinable evidence rather than tradition, authority, or personal conviction. And this experiment, and I quote, clearly demonstrated the hollowness of the basic claim of astrology. Now, let me go to a controversial topic. I want to get into a bit of controversial issue of Andh. However, I want to discuss it without a controversy. One way to do it, one way to discuss it without controversy is using logic. Before you make any judgment about my discussion, listen to my complete argument, complete logic. The expression Andh is commonly used in contemporary political discourse, but my use of that expression is much broader. I am referring by Andh to not only the followers of particular leaders, particular political leaders or political parties or ideologies, but also to forms of religious and devotional loyalty. My use of the expression Andhbhakt refers to a particular attitude, outlook, that is, the unconditional defense of a person or ideology or institution or tradition, even when serious evidence has been presented against it. An Andhbhakt is therefore defined less by what they believe and more by how they hold their beliefs. In simple words, an Andhbhakt is a person who holds rigid beliefs, treats those beliefs as absolutely certain and beyond any questioning, and also refuses to revise those beliefs. That is why such a person lacks scientific temper. Let me give a logical analysis of the conditions under which a person may be classified as Andhbhakt. Let's take premise 1. Every belief that lacks adequate evidence or justification is an unjustified belief. Premise 2. If a person holds an unjustified belief and treats it as certainly true and refuses to revise it despite criticism or contrary evidence, then that person holds that belief dogmatically. Premise 3. Any person who holds dogmatic beliefs, an unjustified belief, expressing loyalty or devotion to a political leader, ideology, deity, scriptures, institutions or tradition is an Andhbhakt. This premise 3 is important. Premise 4. Person P holds belief Q and belief Q lacks adequate evidence or justification. Premise 5. Person P nevertheless treats belief Q as certainly true, refuses to revise belief Q despite rational criticism or contrary evidence, and holds belief Q as an expression of loyalty or devotion. Therefore, in conclusion, person P is an Andhbhakt. Focus on this again. This logical analysis shows that Andhbhakt is defined by the manner in which they hold a belief rather than what they believe or what the belief is about. Therefore, a person becomes an Andhbhakt when they strongly hold a poorly justified belief about a leader, a deity, scripture, ideology, institution or tradition. They also treat belief as certainly true and they feel that they must protect that belief from any rational critical challenge or contrary evidence. That is why this defining feature of Andhbhakti is what I call epistemic insulation, where a belief is placed beyond questioning. To understand my idea of epistemic insulation, I want to give an analogy. Imagine a person living inside an eggshell made up of fixed beliefs. As the shell hardens, prejudice grows stronger and Andhbhakti intensifies. From inside the shell, the person sees the world only through those beliefs and may mistake that limited view for reality itself. Now, scientific temper starts to crack this shell because it encourages one to doubt, to question, to demand evidence. This sort of critical attitude creates cracks in the shell and the person starts to realize that some of the beliefs they once thought as obviously true were nothing but just their prejudices. Next point I want to discuss Nehru, and I want to discuss Nehru's thoughts on scientific temper because any lecture on this subject would be incomplete without considering Nehru and his vision of modern India. In his famous Tryst with Destiny speech delivered on the eve of independence, Nehru declared, and I quote, "Long years ago, we made a tryst with destiny, and now the time comes when we shall redeem our pledge, not wholly or in full measure, but very substantially. At the stroke of the midnight hour, when the world sleeps, India will awake to life and freedom. A moment comes, which comes but rarely in history, when we step out from the old to the new, when an age ends, and when the soul of a nation long suppressed finds utterance." Notice especially the words "when we step out from the old to the new." A little later in the speech, he adds, and I quote, "We end today a period of ill fortune, and India discovers herself again." Again, notice that he is saying that we are moving from one era to another era. What was Nehru trying to signal through these expressions? what did it mean for India to awake to life and freedom, and to end one historical period and step into the new. In India's freedom from colonial rule, Nehru saw opportunity that comes, as he says, rarely in history, to bring a paradigm shift in a country plagued with problems like poverty, communalism, caste hierarchy, economic backwardness, superstition, and intellectual stagnation. To solve these problems, his modern vision of India rested on several connected principles such as national unity, parliamentary democracy, industrialization, socialism, secularism, non-alignment, and scientific temper. In my opinion, the most important principle of these is the scientific temper, which Nehru regarded as essential to India's intellectual, social, and political modernization. Now remember that even though Nehru had established many scientific and technical institutions in India like IITs, IIM, AIMS, and the Atomic Research Institutes, to name a few, his vision of scientific temper was not limited to the scientists or technological experts. On different occasions, he made clear that scientific temper is much more than just what scientists do. For example, he said in a speech at the inauguration of new buildings for the Central Laboratories for Scientific and Industrial Research in Hyderabad in 1954, and I quote, "Science is the search for truth, for facts, and we have to accept the results of our experiments, whether we like it or not. But real scientific spirit is one of pure inquiry. We must keep the doors and windows of our minds open. We must make scientific progress, of course, but it is even more important to inculcate the spirit of scientific inquiry and scientific temper in the people. Only then will our narrow-minded ways disappear and the country can make progress." To understand the audacity of Nehru's vision, we must first understand the condition of the India he inherited when he became the Prime Minister. After nearly 2 centuries of British colonial rule, India was marked by mass poverty, widespread disease, food scarcity, economic underdevelopment, and near total illiteracy. For example, let's see the numbers. In 1951, only 16.6% of Indians were literate. Only about 25% of men and about 8% of women could read and write. Per capita food grain production had fallen more than 24% between 1901 and 1941, and the 1943 famine in Bengal had killed nearly 3 million people. The average Indian born between 1940 and 1951 could expect to live for barely 32 years. That was the life expectancy at the time. And between 175 and 190 infants died for every 1,000 births. Malaria alone affected approximately 1/4 of the population. The economic foundations of the country were also very weak. Modern industry contributed only 7.5% of the national income at the end of British rule. In 1950, only 2.3 million people out of population of 357 million were employed in modern industries. See, the number was very low. And India depended upon imports for approximately 90% of its machine tools. Agriculture, on the other hand, remained trapped in a zamindari system. By 1940s, landlords control over 70% of the land, along with money lenders and colonial government. They claimed more than half of all the agricultural output. By 1951, landless agricultural laborers made about 28% of the farming population. Coming to caste system, the caste system continued to dominate rural life. Untouchability was still widespread. Remember that. And many people had historically been denied education and equal access to public facilities like drinking water places. It was under these extraordinarily difficult conditions that Nehru and the founders of Republic committed India to parliamentary democracy, universal adult suffrage, secular citizenship, humanism, industrial development, social equality, and scientific temper. Imagine that. Their vision was audacious precisely because they did not wait for India to become prosperous, educated, and socially equal before adopting these ideals, these principles. They sought to use the same principles as instruments through which India could overcome its poverty, inequality, ignorance, inherited systems of dominations. Now, let me conclude our lecture today. A single lecture or even few pages of writing or even a book cannot do justice to the long history of scientific temper and also the anti-scientific thought in India. I have tried, however, to present a small but important glimpse of India's own tradition of criticism, inquiry, skepticism, and reform. These traditions have always existed within India's intellectual history. Still, the critical spirit they represent appears increasingly absent from our present social and political climate, which is why I chose this topic of scientific temper. Our education system is actually based on obedience to authority, and as a consequence, people who are ready to conform to authority are seen as good or sanskari. And questioning that authority, whether it is teacher, father, or prime minister, is considered blasphemous. In my opinion, in my own experience, we were never taught to think critically. In schools or at home, education was largely seen as a matter of securing job. If I had a choice, I would have chosen to study humanities or social sciences or philosophy rather than engineering, which many chose in my time to ensure that they get a job. That's all. This is captured in a famous movie character. This sort of attitude is captured in a famous movie character, Farhan Qureshi, from the movie Three Idiots, played by R. Madhavan, who wanted to become a wildlife photographer. As we all know, he hated engineering studies, which was his father's plan. Whenever Farhan challenged or questioned his father about this, his father would get angry and list all the things he did for his son, which I call a form of guilt tripping or emotional blackmail. I think if we think critically, we can easily see that Farhan's father's authority over Farhan was unjust because his father does not have the authority to choose his son's career. And this sort of unjust authority is not limited to child-parent relations. It is much more wider than that. And given that development of scientific temper or critical temper is our constitutional duty, we must reject such unjust authority, whether it is coming from father, teacher, prime minister, or sarpanch. Immanuel Kant, a famous European philosopher, in his famous essay, that is, an answer to the question, what is enlightenment, argues that enlightenment requires one essential condition: freedom, especially the freedom to use reason publicly, that is, to criticize, to be able to criticize publicly. He captures the problem of authority through a series of commands. For example, he quotes, the officer says, do not argue, drill. The taxman says, do not argue, pay. The pastor says, do not argue, believe. In each case, an institution demands obedience and discourages questioning, leading to loss of ability to think critically. This is a very important point. We lose the ability to think critically. However, if we are to make progress and rise above hatred and division, we must, in Kant's own words, sapere aude, that is, to have a courage to use our own understanding. For Kant, and I quote, that is the motto of enlightenment. With that, I take your leave. Happy Independence Day again.